For this lesson, we're going to look at what are called the properties of powers. Sometimes they're known as the exponent rules. We're going to have some guidelines. I'm going to use bases A and B on occasion. They will be, so if these are your bases, one of the rules we're going to have to say is that these bases are non-negative. And I may use some exponents, let's say m and n. These are our exponents. And we will define these exponents to be non-zero. So they just will not equal to 0. We'll deal with what happens if any of those are 0 a little later on. Here's your first property. We're going to say if b is raised to the m, and you choose to multiply this by b raised to the n, what do you get? Well, I'm going to do a demonstration of this. So here's a couple examples. The first example is going to be x cubed times x to the 4th. X cubed is x times x times x multiplied by x times x times x times x. That's x to the 7th. I could come up with the answer very quickly by saying x equals 3 plus 4. It would not have made any difference if I would have said 2 to the 5th, that's a 5 there, times 2 to the 2nd. I would have had parentheses 2 times 2 times 2 times 2 times 2 times 2 times 2. I would have had still a 2 raised to the 7th, except this time I would have gotten it because I would have been able to add the exponents 5 and 2. So what I guess I'm telling you is up here is that if you have the same base in both terms, you can leave the base alone. That's a common mistake. Sometimes people want to change the base and just add the exponents together. B raised to the m plus n. The second popular property is taking b raised to the m and then raising this to the n. Now, what that would mean is, in examples, let's say you have x to the 3rd raised to the 4th. By definition, that's x cubed times x cubed times x cubed times x cubed. Well, each of these is an x times 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 an x. Oh my goodness, that's a lot of x's. What that really is saying is that is x to the 12th. So if I had a different problem and I had to go 5 raised to the 6th, which is then raised to the 7th, well, there's no way I'm going to spend my time writing out all the different 5s out there. What I would like to do preferably, there's my cursor, is say b is raised to the m times n. So that would be 5 raised to the 6 times 7, which means 5 raised to the 42. Let's move on to another one of the properties, and that's where you might say b is raised to the m, divide that by b raised to the n. Again, I think the best way to do examples is to take a look at them. Let's say you had x to the 5th, and you divide that by x to the 2nd. If I actually work out the x's and then divide it by what x squared would look like, you would see that this x would cancel out this one, this would cancel out this one, and it would leave you x times x times x on top, which is x to the 3rd. It doesn't make a difference if there's a number or not. If you say 9 is raised to the 8, and then you choose to say 9 is divided by the 6, you're going to take all these 9s, divided by these many 9s. You're going to cancel 1, 2, 3, 4, 5, 6 of them on top with the 6 of them on the bottom. And you're going to be left with 9 squared. In all the cases, I could have gotten this answer by subtracting the exponents, 5 minus 2, or in this case, 8 minus 6. So what I'm saying is b to the m divided by b to the n is b to the m minus n. You happen to have something in quantities. This is sometimes known as a power of a product. So you have an a and you have a b, and you have it raised to an n. You are actually allowed to look at it as a to the n times b to the n. Which means, for example, if I happen to have 3x quantity to the second, that actually means that it's 3 squared times x squared, which means I can rewrite this as 9x squared. A common mistake made by students is to say 3x squared is 9x squared. Remember, if there's no parentheses, the square is only being applied to here, and therefore it still is 3x squared. If for some reason you want to have a little bit more fun and you say 4 times x times y cubed is raised to the 5th, that's a 5 there, just in case you were wondering, 5. Then you could say this will be 4 to the 5th. This would be x to the 5th. And this would be y cubed to the 5th. Well, 4 to the 5th is 4, 16, 64, 256, 1024. This would still be x to the 5th. And then I can go back to my rules I just learned. Y cubed times raised to the 5th would be y raised to the 3 times 5. So my final answer would work out to be 1024 x to the 5th, y to the 15th. Let's move on to another set of rules, which says, okay, well, if you've got a over b raised to the n, you're allowed to break it up as a to the n over b to the n, which means if I happen to have an example, let's actually use a fraction, 3/5. Boy, my 5s are not looking good tonight. That would be the same as 3 squared over 5 squared, which is 9 over 25. Now, for all these rules, if you go one way, you can also go backwards. So for some reason, if you ever happen to have 9/25 and you realize that's the same as 3 squared over 5 squared, you're allowed to go back and say, well, that's the same as 3/5 quantity squared. If you happen to see a problem that said, you know what, I have 36 x to the 4th, you can realize that 36 is 6 squared. You can realize that x to the 4th is x squared squared, and you would be allowed to write the quantity 6x squared quantity squared. The zero exponent theorem, and it's actually quite simple. It says that if you take b and you raise it to the 0, we will define this to be the value of 1. Now, I hate to say define because there's actually a theorem, and the reason for that is that we can actually look at an example is, let's say we have x raised to the n over x raised to the n. Well, by definition, x raised to the n minus n would have to be x to the 0. But since these would cancel out and equal 1, your definition is that 1 would have to equal x to the 0. This is true for any number except for b cannot be equal to 0. By definition, 0 to the 0, for all practical purposes, is not something that we can define at this time. So it's really is sort of a D&E type situation.